Continuous variables like age, systolic blood pressure, weight are typically described taking three approaches. First, you provide the central tendency like mean and median to find the typical values. Then you provide the spread that is provided through standard deviation or percentile to see the variability in the data. And then you provide visualizations like histogram or box plot to understand data distribution visually. The central value is the most important summary measure for a continuous variable. We typically describe it using three measures. Mean, which is simply the average calculated by adding all the values and dividing by the total number. Among all the measures of central tendency, the mean is the most commonly used and the most useful measure. For example, if we want to determine the average diastolic blood pressure in our heart data set, we can just copy this by Control C, open a new spreadsheet by Control N, and then paste all the diastolic values from the heart data set over here in column A by Control V. And the average can simply be calculated by the sum of all the values. You know what, we can just do it over here, is equal to sum of all the values, that is A to A. So this gives us the value 444,633, and we already know that the total number of the total count of the values over here are 5,209. So if we divide it by the total number of observations 5,209, it should give us the average, which is 85.36 millimeters of mercury. Median is the middle value when the data is ordered from smallest to largest, or the other way around. For example, if we want to determine the median diastolic blood pressure in heart data set, let's delete this one out. We do not need this ever again. Okay, so we will sort these values from smallest to largest, so largest to smallest. And now we see that the smallest value, that is 50 millimeters of mercury, is on the top, and the largest value should be at the bottom, 160, pretty high. Okay, anyways, the median will be the middle value of all these diastolic blood pressures over here, which should be 5,209 divided by 2. Okay, the median should be 2605th value. If it was even, then we will take the middle two values and take the average of them. But as we see here, we do have an odd number there, so we will just pick up the 2605th value from here. Let's scroll down. Keep an eye on all the number of the particular number by sequence of these diastolic blood pressure. 2605th is 2605th value is 84 millimeters of mercury. So the median is 84 millimeters of mercury diastolic blood pressure. Feel free to save this sheet in your computer, or you might like to delete it. We are not going to use this spreadsheet again in this course. Okay, mean and median are often provided together because together they provide a much clearer picture than either of them alone. For example, over here we see that mean and median are quite close to each other, indicating that both of them are good representative of the center of the diastolic variable. The mean is slightly pulled to the right because of, you see the extreme values on the right. But as you can imagine, median, which is simply the central value, is unaffected by these outliers. Here is the histogram for systolic blood pressure. We will learn more about histograms in a in a few minutes. But what we see here is that mean and median are slightly drifted apart, not too much, but still we see that median is 132 millimeters of mercury and mean is 136.9 millimeters of mercury for the systolic blood pressure. And we see there are plenty of extreme values on the upper end of systolic blood pressure, which is pulling the mean towards them. Again, the point is that when they are reported together, they provide a better understanding of the distribution of the data, and also detect outliers or skewness in the data. The third measure of central tendency is mode, which is simply the most commonly appearing value within a variable. For example, say we have maybe 82 millimeters of mercury blood pressure coming like say 50 times. So that would be the modal value of a diastolic blood pressure. But this measure is rarely used in statistics. We'll talk a lot about measures of spread, and two common visuals are typically used to describe continuous variables: histogram and box plot. Histograms, as you see on the right, they have bars, and each bar represent a range of values. The height of each bar corresponds to the number or percent of observations falling within that specific range. For example, in this histograms for the systolic blood pressure, we see that each bar shows the percentage of people whose systolic blood pressure falls within each interval. Taller bars indicate more observations in that range. Box plot, as you see on the bottom of this visual here, it describes the data by providing certain key features. For example, you see this line, this represents the median. The diamond shape is for the mean, and if you remember, the mean was slightly pulled to the right side because of the extreme values on the right. There is also the description for the box and all the whiskers, which are on both the sides. We'll talk about that in a few minutes. So in summary, we describe continuous variables first by providing their central tendency in the form of mean and median. Then we provide the spread in the form of standard deviation or percentile. And then we also provide one visual, either histogram or box plot or both.